Thank you, Jamal. TED lectures usually start with this epiphany moment. We've heard a few today, and when you see the TED lectures online, there's always this beginning where the presenter would tell you about the one incident, that one moment that changed his life. And the story of the project that I want to present to you today, and my story with it, the eco-house that we're currently building at the German University of Technology here in Oman. This story doesn't really have this epiphany moment. I tried and tried and tried to find what actually turned me around in this topic, and I couldn't really find it. But then I remembered these two stickers that I had in my childhood. So I grew up in Germany in the 70s, and that was the time when you turned off the oil for us, so energy became a topic. And on the left, you see this first sticker. It says, "Ich bin Energiesparer." I'm saving energy. It was on the worst gas-guzzling cars. Everywhere you could see the sticker. And the second sticker that I then remembered says, "Atomkraft, nein danke." It says, "Nuclear energy, no thank you." And so this topic of energy efficiency that we're dealing with in this eco-house, it was always around. And between these two stickers, you can see the dilemma. On the one hand side, you should reduce the demand for energy. On the other hand, you should not supply it with non-renewable energies. So somewhere here is the beginning of the green building movement, of eco-houses. But in the 70s, 80s, the eco-houses were still quite a freak show. They were often a compromise between comfort and conviction, so your intention was much more important maybe than the result. So this is kind of the background. It was always around me, this topic, but I had never really looked into it. And the change came then when suddenly the Research Council here in Oman had asked us as a university to take part in a competition where we're supposed to design, to build, to operate, to monitor an energy-efficient building. And when you drive through the country, you see these kind of villas everywhere. Actually, there's only this one type of building in Oman. Everything's a villa. Even the Research Council sits in a villa with a swimming pool. Yeah? But that's how it is here. But we all know that this kind of building and construction method is not really appropriate to the climate. But the real problem is that the energy demand is so high that it cannot be sustained in the current mode of operation. The point is that there are already many villas here, and a friend of mine told me he had to get up at 6:30 this morning to get here to this presentation. So you see, we have very big city villas everywhere, and there'll be even more villas if you look at the demographic forecast. So the upper part of this graph, that's the population distribution in Oman. The upper part are the people who already have a plot. The light brown are those who are already born and will ask for a plot very soon. And the dark brown is what is forecasted to come as population. At the same time, the energy demand is rising dramatically. And therefore, we work with the next generation of architects who are here, part of our team, to find out how we can actually change the way that buildings are built here, and we try this with a prototype. I'm not going to go very much into the climate analysis here. You might have your own experiences. I think this time of the year is when you can already switch off the aircon, or at least you could. So the question is, how do we translate the knowledge that is around about green buildings into making one in Oman? And here is our concept. This dog is a regular visitor on our site. This is our site on the campus. And I think this dog is instinctively doing everything right. He has found a comfortable place on a hot afternoon. So he's sitting in the water. It's cooler inside than outside. It is surrounded by a natural material. This is the mud that we make our mud bricks from. There are a bit of native plants around. Some weed came flying and is now growing here. And he has a good view. There's natural ventilation and so on. So translate this into a real building, and you see that we start with strategies more than actually the design of the building. So what we want to communicate is a package of 12 possible strategies that can be applied to any building here in Oman. The first one is pretty easy. A compact volume is very good in this climate. If the area to surface ratio is such that the impact of the sun is reduced, the impact on the surface, then this is already a positive contribution. The second strategy is the orientation. Here you see George Bernard Shaw. You might have heard of the British author. And his writing cabin in his garden had the optimal orientation because it was constructed on a pin. So he could just turn the whole building with the sun and always have a nice warm cabin, even though the climate in the UK is rather cold. So what we're doing is we take this cylindrical form of our building and we cut it open in the direction of the sunrise on the 21st of June morning, and we cut it the other side on the line of the sunset. So that makes sure that we never have direct sunlight hitting onto the openings of our buildings. Second or third strategy here is natural ventilation. You just have to look at the old Omani buildings. Here's a ruin from Ibra, where you see that the windows have very smartly been distinguished into one element that is for lighting, the other element is for air. So if there's good natural ventilation, you can reduce the energy demand. Everyone who spends a little time in a desert climate knows that you have to protect yourself well, and that is not only for the turban, but also for the sunglasses. So our shell of our building is very highly insulated. We will use lightweight bricks, we will use a natural insulation material, and we will use mud bricks on the inside. So we have a fat 60 centimeter wall, almost like in the traditional buildings. We will have high quality windows, and the whole building will be airtight, so that we can really control the loss of colds and the gain of heat. The next strategy is called thermal zoning. I spent about a year working and living in Japan, and this device here is called a kotatsu. Kotatsu is very helpful when you look at the architecture in the background. Actually, Japan has a pretty cold climate in winter, but the walls are very thin, so the room is very cold. The heat and the comfort is provided by a table in the middle that also has a stove and blankets attached to it. So there's a warm core and a cold shell. We do the opposite. So within this protective envelope, we have a house in the house, and this is what we will cool, so that there's a minimum of loss of energy that we put into the building in order to cool it. So with these strategies, the previous diagram that I showed you, which showed a continuous demand and consumption of energy over the year, you see the energy on the vertical axis and the months on the horizontal axis. We can cut out, with these strategies, we can cut out 6 months of having to air condition the building. So we will just shut off any cooling system, and we're quite optimistic that this should work out. Now we have to see what do we do in the hotter months. In the hotter months, we will cool the building with a technical device called radiant cooling. So radiant cooling was already used by the Romans. Here you see a drawing of a Roman bath, and the Romans warmed up, they heated the surfaces. You can see the fire in the underfloor heating, so that the surfaces are warm. You all know the situation when you drive with your car here in Oman in summer, put the aircon on full heat. You think it's cold, but actually the radiation from the windows is what gives you a headache after an hour or two. So if the surface temperature and the air temperature don't really match, then you're not in a comfortable position. Therefore, in our eco house, we will use a chilled ceiling, so we will cool the ceilings with water in order to have a cold surface, and it's a cooling system that is silent. So there's not the usual noise that we will hear here, but in the hot months, we need to bring in cooled air in order to have a hygienic air exchange. But we will not lose the energy that we put into cooling this air if we look at a device like this. This is a strategy to recover energy, and this was done by a New York artist called Michael Rakowitz, who built these little shelters for the homeless by switching a plastic tube to the exhaust fan of houses so that the warm air could be reused. And we will reuse the cold air that leaves our building. Again, we can save some energy. We need efficient appliances in an eco house. And a very good example is Omani Shua. So if you don't have much wood to fire your barbecue, you dig a hole, which is very efficient because there's little heat loss, and you can make wonderful food if you wait for 24 hours and then open the pit again. So with efficient appliances in mind, we will install very energy efficient lighting, white goods, and so on in the building. This gives us another change and another reduction in the energy consumption, so we can, in the summer months, push down the demand of energy that we have. Of course, we will produce our energy with solar power, and this is a picture of the first built solar power plant in the world. That was in 1912 in Egypt. So it was started in this region, in the Arab region. Now, at the moment, every second solar panel is installed in Germany, but in this region, it makes much more sense. So we want to show that we can provide enough energy through solar power to run our building more or less independently. There's a number of other strategies beyond the direct energy demand, which is more the so-called gray energy. So we look at recyclable materials. We will make mud bricks, but not in the old-fashioned way. We now have a little compression machine to make our own mud bricks, but we believe that this will provide us with a wonderful indoor climate. We will cut up the hoarding of from our site, all the shuttering wood, recycle it, make the furniture from it, and so on. We will further treat our sewerage water, and here we work together with a company, Bauer, that has established an enormous project here in Oman. I don't know if you're aware that the biggest natural water treatment plant is actually in this country. It's in the desert, where the contaminated water from the oil production is cleaned and reused. So we will do a small little reed bed and water treatment plant in order to have our own water, which we can then use to irrigate a garden with native plants. So we will not use any imported plants. We will use native plants, and we're working together with a landscape architect here who is also resident in Oman and an expert in this. So these plants do not need fertilizers of the same amount, if any at all. They need much less water, don't need pesticides. They can provide a habitat for animals. So the whole environment gets much, much more local and, I think, culturally valuable. Now, this is the building. It's growing slowly. You're most welcome to visit the site out here in Halban. So step by step, this building is growing now, and in April, it's supposed to be completed. And this is a wonderful moment when you have worked on a project for over a year, and then suddenly this shape and these forms and the spaces that you have kind of seen with your inner eye, with your imagination behind your eyes, is suddenly evolving in front of your eyes, and it's really there. And this is a wonderful moment. But when you think into the end result that we usually show, which is this rendering, then this is only one result. And if I can connect to what Neil has presented with Moon just now, for me, the most interesting experience in this project is that the real quality that we want to achieve is not a certain form in this building, but it is a certain temperature, it's a certain humidity, it's a certain comfort. So the quality of architecture that we try to provide here is something that you cannot see. And this is, for me, maybe the missing epiphany moment from the beginning, that here the design quality is actually invisible. Thank you very much.